Alright, this first video is a brief coverage of calculating average speed. I'm just going to work two examples, and I think that should be enough. It's a pretty simple concept. If a NASCAR driver could complete the Indy 500 without stopping, how long would the race take if the driver's speed was a constant 200 miles per hour? Alright, may want to read that question again. I'm going to switch to a clean slide so I have some space to work this out. Alright, so for those of you who are not race fans, the Indianapolis 500 is a 500-mile race. And the question asks us, traveling at 200 miles per hour, how long would it take to finish the race? Okay, so our total distance is 500 miles, and our speed is 200 miles per hour. Alright, and now we want the time it takes us to finish the race. For this, we will use the concept of average velocity. So the speed here, 200 miles per hour, would be considered our average velocity. And if you look at your textbook, page 22, there's a great definition of average velocity. Average velocity is displacement over elapsed time, and you should flip to page 22 if you haven't already to follow along. So the formula for average velocity is V average, change in position over change in time. Now we're going to have to adjust this a little bit because we're not talking about a vector here. I gave you speed. So we can actually remove the direction part and just make this speed equals our change in position. Let's call it distance since we're not dealing with the vector displacement. So speed equals distance over time. So this equation I just wrote down here, s equals d over t, this is the non-vector version of the equation up here. Alright, now we're pretty much ready. So we are looking for time. So we're going to take this equation here, and before putting any numbers in, that's right, before putting any numbers in, once again, before putting any numbers in, we're going to solve for time. So I'm going to use my therefore symbol. Alright, if I'm solving for time, the first thing I want to do is get t by itself. If I were to multiply by t on both sides of this equation, that would at least get t out of the bottom. So now I have s times t equals d, and I can take that and divide by s, and I get time equals distance over speed. Now I can substitute in. My distance is 500 miles. My speed is 200 miles per hour. And if you divide that out, sorry, I'm going to take this to the top. So divide that out, and you get 2.5 hours. What I would like you to do is confirm that if you carry out those units, so just do the equation with units, miles and miles per hour, that the units do work out to hours in the end. Also, you can check my math on the rest of it. So this is one use of the average speed equation, which we got from just taking the direction out of the average velocity equation. Alright, this next example problem has a lot to it. An airplane travels 3,100 kilometers at a speed of 790 kilometers per hour, and then encounters a tailwind that boosts its speed to 990 kilometers per hour for the next 2,800 kilometers. What is the total time for the trip? What is the average speed of the plane for this trip? Alright, this is going to take a couple parts. First, let's get how long the first part of the trip takes, 3,100 kilometers at a speed of 790 kilometers per hour. Using that average speed equation, s equals d over t. And just like in the last slide, we solved for t. So I'm going to just refer you back to that last slide, point out that t time equals distance over speed. Alright, and now let's sub in. 3,100 kilometers divided by 790 kilometers per hour. For convenience, I'm going to round to the nearest tenth here. When I divide that out, I get 3.9 hours. Right, might want to confirm my math there. I got 3.9 hours when I divided 3,100 kilometers by 790 kilometers per hour. Okay, so what I'll do now is just record up in the corner time for the first leg of the trip. Whoopsie. Time for the first leg of the trip was 3.9 hours. Now let's do the second part. Its speed is now 990 kilometers per hour for the next 2,800 kilometers. Same equation as before. I'm going to skip the working it out part and just go straight to t equals distance over speed. 2,800 kilometers over 990 kilometers per hour. Okay. Again, rounding to the nearest tenth, I get 2.8 hours. So my second time, I don't know why that keeps happening. Let me put that back. Second time is 2.8 hours. Okay, so now to get my total time, I'll just add up these two times up here, T1 and T2, which is 3.9 hours plus 2.8 hours, and I get 6.7 hours. Alright, now we're going to calculate the average speed for the trip. So, referring back to the equation, speed equals distance over time. Alright, our total distance is going to be 3,100 kilometers and 2,800 kilometers. So, 3,100 kilometers plus 2,800 kilometers. And our total time we just found was 6.7 hours. Alright, 3,100 plus 2,800 is 5,900. 5,900 kilometers divided by 6.7 hours. I'm going to bring my answer up here. Sorry, these slides are too small for my pen. And I get the average speed was 880 point, around the nearest tenth, 6 kilometers per hour. So notice I just took total distance, 590 kilometers, divided by total time, 6.7 hours, to get the average speed. That's all it is, total distance over total time. Alright, we'll do some discussion questions in class tomorrow. Otherwise, that's it. The other video on this post is how to study for tomorrow's quiz.